In this lesson, we are going to graph a parabola from a quadratic equation written in standard form. The first thing that we want to take a look at is what does standard form look like? Hopefully most of you remember this. It is y equals ax squared plus bx plus c, where our a value cannot equal 0, because if our a value was 0, we would not have a quadratic anymore because this x squared would go away. So first we want to remind ourselves what we already know about parabolas. If our a value in standard form is greater than 0, then our parabola is going to open up. If our a value is negative or less than 0, our parabola is going to open down. If our a is bigger than 1, we know that we are going to have a narrower graph or skinnier than our parent function y equals x squared. And if a is less than 1, we're going to have a wider graph than y equals x squared. The bigger the number, the skinnier it gets. So what's new in this lesson is we have a new equation to find our axis of symmetry. And that equation is negative b over 2a. Remember that our equation has to be in standard form before we can plug it into this formula to find the axis of symmetry. The vertex has the x-coordinate of this very same formula, negative b over 2a. And in order to find the y-coordinate of our vertex, we just plug our x into the equation to find y. The last thing that we're going to talk about is that we now know that our y-intercept is at our c value. So if our x is 0, our y-intercept is c, and that will give us another coordinate point. So let's take a look at our first example. We have y equals x squared minus 2x minus 3. The first thing I'd like you to do on every time is label your a, b, and c values. Until you get really good at this, this is a good idea. So remember, if we don't have anything in front of our x, that number is just a 1, so our a value equals 1. As a reminder of our axis of symmetry formula, we have negative b over 2a. To find that axis of symmetry, we plug in our values. We have negative b, which our b is negative 2 over 2 times our a value, which we know is 1. So if we have a negative negative 2, we know that minus a negative gives us a positive, so we have 2. 2 times 1 we know is just 2, and 2 divided by 2 is 1. So our axis of symmetry is on the line x equals 1. Plugging that into our vertex, remember our x value of our vertex is just the axis of symmetry value. So then, to find the y, we plug that x value into our equation. So our x squared is 1 squared minus 2 times x, which is 1, minus 3. 1 squared we know is just 1. 2 times 1 is 2, so 1 minus 2, and then minus 3. So we have 1 minus 2 minus 3, that gives us a negative 4. So our first value in our table is our vertex, which is 1, negative 4. And to find the x-intercept, we know that we can just use our c value. So that is negative 3, and we know that in our y-intercept, our x value equals 0. So we have another point to plot on our table, 0, negative 3. Okay, so now that we have our 2 points, our vertex and our y-intercept, we can start plotting. And we know that our axis of symmetry is at x equals 1, so we'll quickly sketch that. X equals 1. Okay, and our vertex is at 1, negative 4. So go ahead and plot that point. Our next point is our y-intercept, and that is at 0, negative 3. That will be right here. Now, if you'll remember, The axis of symmetry acts like a mirror on the parabola. So since we know this is our base point, our vertex, and our next point is 1 over from the axis of symmetry on the left side, we also need one on the right side, mirroring that point. So now we have a point at 2, -3. And we need to pick one more value at least because we need at least 5 points. So I'm going to pick -1 because it's an easy number and we haven't used it yet. So if I pick -1, let's plug that into our equation. So we have -1 squared minus 2 times -1 minus 3. Now let's go ahead and evaluate this little expression. -1 squared is -1 times -1, which is just 1. -2 times a -1, we have two negatives, so it becomes positive, and 2 times 1 is 2. So we have 1 plus 2 minus 3. We have 3 minus 3, which is just 0. Okay, so our next point is at -1, 0, which is right up here. And again, mirroring across this axis of symmetry, we are 2 away on this side, so we need to go 2 away on this side. And that point will be at 3, 0. So we have all 5 points here. Go ahead and draw your parabola. And that is how we graph using the standard form. Okay, our next example is y equals x squared plus 3x minus 4. Once again, the first thing I'd like you to do is label your a, b, and c values. A is invisible here, which must mean it's a 1. So our axis of symmetry formula, if you remember, is -b over 2a. Plugging in our values, we'll get a negative, our b value is 3, over 2 times our a value, which is 1. So we'll get a -3 over 2, because 2 times 1 is 2. And if fractions are difficult for you, we can change that into a decimal, which is -1.5. So our axis of symmetry is on the line x equals -1.5. We also know that when we're finding our vertex, our x in our vertex is the axis of symmetry line, so -1.5. And if we would like to find the y value, we need to plug -1.5 into our equation. So, use a different color here. We have -1.5 squared plus 3 times -1.5 minus 4. Go ahead and use your calculators if you need to. -1.5 squared is 2.25 plus 3 times a -1.5, so we should be changing this plus sign to a minus because a positive times a negative is a negative. 3 times 1.5 is 4.5 minus 4. So we have 2.25 minus 4.5 minus 4. And that is going to give us a -6.25. So our y value for our vertex is -6.25. Last thing we want to look at when we're looking at our equation is our c value, because that is our y-intercept. So our y-intercept is at -4, and that is where the y-intercept is where x equals 0. So our y-intercept is at 0, -4. Okay, so we have our information. Our axis of symmetry is on the line x equals -1.5. So that'll be right in between -1 and -2. So go ahead and draw your axis of symmetry in your graph. Okay, our vertex, remember, is at negative 1.5, negative 6.25. So let's estimate that our vertex is about right here. So in our table, we have negative 1.5, negative 6.25. The other point that we are sure of is 0, negative 4. So let's go ahead and plot that. We would like to mirror this point across the axis of symmetry. So if we have a point 1.5 units away from the axis, we have to go 1.5 units this way, which will be at the point negative 3, negative 4. Okay, and we have to find one more point to pick from here. So I'm going to pick the line at the x equals 1 because we haven't used that yet, and 1 is an easy number. So if we plug 1 into our equation, we're going to get 1 squared, which is 1, plus 3 times 1, which is 3, minus 4. So we have 1 plus 3 is 4, minus 4 is 0. So we have another point at 1, 0. You'll notice we are 1, 2.5 away from our axis of symmetry. So if we go 1/2 and 1, 2 the other way, we'll find that our last point is at negative 4, 0. So we'll go ahead and draw that parabola. And that is how you use the standard form to find a parabola and graph it. As a quick review, we just want to remember that we need our standard form to use this method, and a quadratic and standard form is y equals ax squared plus bx plus c, where our a value cannot equal 0. The vertex is at the point x, y, and remember our x value is found when we find the axis of symmetry at negative b over 2a. So our vertex is xy, and our x value is the same formula we use to find our axis of symmetry. And the last thing that we want to remember is we have another easy point that we can plot, and it's the y-intercept because it's just our c value. So we have an extra point at 0, c. And that will conclude this lesson.